opening up, increasing to infinity. From 0, opening up, increasing towards infinity before hitting the vertical asymptote. Done. In the middle, coming from negative infinity, crossing at 0, -2, coming back to negative infinity. From negative infinity up to the maximum, down to negative infinity. Final step, decreasing from positive infinity to 0, opening up. From positive infinity, decreasing to 0, opening up. And that's the function 2 over x squared minus 1. Yes, you can always check with the graphing calculator. You should always do that. But don't just get the graph and then try to match things to match the graph. No, please don't do that. So the standard viewing window will work for this function. As you see, this is incorrect, right? It appears that the x-axis and the function are one and the same. No, they're not. Okay? So approaching 0, opening up, going to infinity on the left-hand side of the vertical asymptote at -1, which is not presented. Coming from negative infinity to that maximum of 0, 2, and then comes back, -0, -2, and then comes back to negative infinity. Again, please do not copy something like this, because then I know that the work wasn't done, but just the copy, somebody copied the graph from the calculator. And we know that this is not possible. They're not one and the same. Any questions about the graph? This is a major topic in what we studied here. Any questions, any concerns about this problem? Please ask anything before we move on to the rest. Do you find this difficult?
No, but could you explain how you got the vertical asymptote again?
Yes. Yes. A rational function cannot have denominator 0. If the denominator is 0, then x is plus or minus 1. But we know that at x equals plus or minus 1, the function is undefined. So that's why I drew something like this, signifying that I cannot put a number anywhere here. The function does not exist. The derivative cannot exist. So this comes from the review chapter when we determine domain. So we have to write that x squared minus 1 does not equal 0. We factor or we take square roots after moving 1. And we know that this has two solutions.
Gotcha.
Now, the question is, how did we get these symbols? Well, if a function has a vertical asymptote, a rational function has a vertical asymptote, left and right have to be infinity. Remember, unless there is a factor that I can remove. But there is no factor that I can remove here. How did I get these symbols? I put the function in the graphing calculator, and I plugged in negative 1.1, and I got a positive number. I plugged in negative 0.9, and I got a negative number. I plugged in 0.9, and I got a negative number, and I plugged in 1.1, and I got a positive number. There is an easier way, but calculator works. I need to determine the limits, because if I don't have these limits, I don't know where the function is going. Is it going this way? Is it going this way? But this told me positive. And on the other side, from positive infinity to 0. And in the middle, it has a maximum coming from negative infinity and back to, so This basically is what you see here. And what I'm showing here is exactly what you see in the middle. What I'm showing here is what you see here. And here, from 0 to infinity. So this is basically a mirrored image of what you see on the graph. That's why I disregard everything else. I can't read all this. It was used. It's here now. And it gives me the symbols, opening up, opening down. So I don't care for that anymore. Doesn't mean anything. Once I used it and I summarize it in the table, that's all I needed. Is that better?
Much. Thank you.
Thank you. Okay. Back to page 314. I hope I'm not logged out. Where is my book? Who knows where my book is? Here it is. Okay, perfect. We want 314, 314. And I was looking at 25. We're asked to determine the absolute max and absolute min. So again, this is another example in which we have to use this table. But not the whole thing, much less. So let me copy 25. And that's on page 314. So let me say that this is done and this is done, will be done in a minute. So in 25 we have f of x equals natural log of x to the third minus 3x plus 4. The interval given to us is negative 3/2, comma 3/2. Good. So the same idea. F prime of x and f of x. We're not asked to graph. We go to the second derivative only when we're asked to graph most of the time. And there are other situations. But negative 3/2, 3/2. That's all we have. We don't have to determine anything here concerning the domain. It is given to us. That's all I'm asked to put in. Do not go beyond this because that's what we have. So can anyone give us the derivative of this function? Natural log of a function. How do I determine the derivative of natural log? Anyone? Anyone, please? The derivative of natural log of x cubed minus 3x plus 4.
Is it 3x minus 3?
So it's 1 over the function times the inner function prime. 1 over the function times the inner function prime. And when we set this equal to 0, because it cannot be undefined, if this is 0, then natural log does not exist. So undefined, it does not. This has to be 0. It's the only quantity in the numerator. 3x squared minus 3 equals 0. Of course, I'll divide by 3, and I get x squared minus 1 equals 0, and I get the same situation that I got 3 minutes ago. Both fit in here. You have to be careful, because if they don't fit in there, then the critical numbers are not in the domain, and I just have to study the sign. In a moment, I will plug in the function, this number to get this y value, this number to get this y value, this number 1 to get this y value, and of course here. But we have to study the sign of the derivative first. This quantity, if you remember the domain, this has to be positive. And has to be because we are given the domain here. So there is no point. You can plug it in like we just did, and plug in a number to the left, to the right, but there is no need because this is always positive. So I have to study the sign of 3x squared minus 3. When I plug in 0, I get negative. When I plug in 1.5, I will get positive. When I plug in negative 1.5, I will also get positive. Now quickly I have to determine these four values, plugging these numbers in the function. So with a calculator, I have natural log of x cubed minus 3x plus 4. And I only care about these four numbers, negative 1.5, negative 1.5, negative 1, 1, and 1.5. And I copy them in the table. 1.63, 1.79, 0.69, and 1.1. Okay, now we are making a decision. From 1.63 to 1.79, the function is increasing, and that's supported by the sign of the first derivative. From 1.79 to this is decreasing, that's correct. And from here, it's increasing, and that's correct. So let's start with this point. What type of point is negative 1? 1.79.
Max.
Very good. We'll decide in a moment if it's relative or definitely relative, but we are asked to find absolute. What about this point, positive 1.69?
Mid.
Yes.
Mid.
Yes. So since this is the smallest number, this is the absolute min, and this is the absolute max because it's the largest number. So what about this point? It's nothing because it's at the end point of the intervals, end point of the interval, end point of the interval. And it's not the absolute max because there is one higher. And it's not the absolute min because there is one lower. The same thing here. There is something higher than 1.1, which is 1.79, and there is something lower. So that's it. So negative 1, 1.79 is the absolute max and also relative. It's in the middle of the interval. And 1, 0.69 is the absolute min, but also relative. It's in the middle. That's it. Let's see, 25. 25, where is my book? I lost my book. Why did I lose my book? Where is my book? Why did I lose my book? I didn't. Okay, 329. Let's also look at 25. If any of these problems you don't need to, because we worked on them over and over, we can move on. So in 25, they're asking us to determine maximizing profit. Find the maximum profit and the number of units that must be produced and sold in order to achieve that profit. And I picked 25. So 25 on 329. Okay, so we have r of x, 50x minus 0.5x squared, and the cost 4x plus 10. And they want us to find the maximum profit. Now, of course, we have to create the profit first. We don't have the profit. So can anyone tell us how to find the profit? We have the revenue and I have the cost.
Revenue minus cost.
Yes, r of x minus c of x. But please remember, you have to subtract all terms in the cost. I've seen it so many times. My wonderful students distribute -1 to 4x, but forget to distribute -1 to 10. So P of x equals 50x minus 0.5x squared, but minus 4x and minus 10. I have to arrange this correctly as negative 0.5x squared. 50x minus 4x is positive 46x and minus 10. Please remember to do this. Subtract all terms in the cost function, and then 50 minus 4 is 46. What do I need to find in order to determine the maximum or minimum product? I meant to say profit, of course, not product. What do I have to find next? We're asked to find the maximum profit or minimum profit. Of course, we're always looking at maximum. What do I have to find?
The derivative.
Yes, of course. So bring down 2, so I get negative x plus 46. This is never undefined, but p prime of x could be 0 as x equals 46. I have to show with the table that this gives a maximum. Very simple. All I have to show is this. P prime of x and then p of x. X is the number of units. Of course, this makes no sense. I don't know where it's going. But this is 0. And I study the sign by plugging 0, and I see it's positive and then negative. So obviously, this must be the maximum. What is the maximum? I go back to the profit and find P of 46. This will be the maximum, as we know.